welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Up to now we have learned multiplexer and types of multiplexers, and we have seen different problems on multiplexer concept. Now let us move on to demultiplexer. It is exactly opposite to multiplexer concept. Now let us see how the demultiplexer works. So here demultiplexer. Sir, here demultiplexer, it is the first thing we can say, it is a combinational circuit. It is a combinational circuit. And second thing we can say that we can call it as it is opposite to multiplexer or mux, we can say. Because it is opposite to multiplexer circuit we called as many to one circuit, which means many inputs to one output we said. And now this is exactly opposite to multiplexer, so I would like to call it as one to many circuit. Here we can say one to many circuit. This is called one to many circuit. And multiplexer we call as here parallel to serial circuit. Here multiplexer we called as parallel to serial circuit because it is opposite to multiplexer. Can I call it as here serial to parallel circuit? Yes sir. Here serial to parallel circuit, and the circuit diagram of demultiplexer is like this. Here we can say that the circuit diagram of demultiplexer is like this. Here it is having only one input, here I we can say, and now it is also having select lines. Here let me take here S0 and S1, and now outputs are we can say Y0, Y1, Y2 and Y3. So that here one input and four outputs, we can say 1 into 4 demux. Here 1 into 4 demultiplexer. This is the circuit diagram, basic circuit diagram of here demultiplexer. And also we can see that this is, we can call it as 1 into 4 basic circuit or basic demultiplexer circuit or IEEE standard circuit we can also call. So here demultiplexer is also combinational circuit. So because it is a combinational circuit, its entire operation is as like the combinational circuits what we have learned. It is not having a memory, and it should not have a clock circuit, and it should not have a synchronization, and it should not have a feedback, and its output is completely depends on its present input. Whatever we are applying the input presently, so based upon that input the circuit is producing output. That is the process, basic process we have learned, and the same process is applicable even for demultiplexer. And also when we learn demultiplexer circuits, like here the demultiplexer circuits, the fifth point I can say that here the circuits are available as 1 into 2 demultiplexer and 1 into 2 demux, and we can say 1 into 4 demux, and we can say 1 into 8 demux. These are the first type of demultiplexers. Here these are the basics, first type we can say. And there are second type of circuits also. Here construction of 1 into 8 demux, 1 into 8 demux using 1 into 2 demux. This is what the second stage, or we can say second type of structures. Mostly we may be getting the gate questions from this kind of equations. Here when we learn multiplexer concept, here sir we have seen few logics based upon those logics, we could be able to answer any question if they ask. If we can understand the same procedure also here, we can able to answer even how many number of 1 into 2 demultiplexers are required to implement 1 into 8 demultiplexer in such a way that whatever the question comes, we may be able to answer if we can understand few logics. And now let us move on. Here the sixth point, if you can say that electrical circuit, electrical structure of here the demultiplexer is like this. This is I input and we can say outputs are here. There are two outputs. We can say this is Y0 and then this is Y1 we can say. Now here this is electrical switch and based upon the priority we can say here this is S, we can say select line or control line. If S equal to 0, it will select Y0. Here Y0. Here if S equal to 1, it may be selected to another Y1 or something else. Based upon the select line, here the switch is electrical switch is connected to output and then the connected output we here the input will be the data which is available in input will be forwarded to corresponding output. These are the basics. These are the basics. And now based upon these basics, let us try to understand the concept of 1 into 2 multiplexer first of all. Yes, please note it down. Make a heading 1 into 2 demultiplexer. Here the first question, let us try to understand 1 into 2 demultiplexer. 1 into 2 demultiplexer. Sir, here the name itself indicates here 1 into 2 demultiplexer means here we need to find the number of inputs and outputs. Here we can say number of inputs are here only 1 and now here number of outputs are based upon the question. Here we can say number of outputs are 2. Sir, here the circuit diagram we can say if we see the basic circuit diagram of demultiplexer, we can say 1 into 2 demux. 1 into 2 demux. Here only one input we can say I. And now outputs are here Y0 and Y1. Here there is a select line called S. We can say select line. So now let us try to understand. Here after identifying number of inputs and number of outputs, we need to construct the truth table first of all. Here to construct the truth table, second point is truth table. Truth table. Sir, here we have S. S is the select line and now here Y0 and Y1 are the outputs. Here only single variable so that there are two variables we may apply as inputs so that there may be a chance of two variations. First one is 1, 0 and then second one is 1 we can say. Sir, the truth table will be like this. Here the moment when we apply S equal to 0, automatically here I is connected to Y0. Here I is connected to Y0. For the better understanding, I would like to write here this is Y0 and then this is Y1. Here, sir, the moment when we apply S equal to 0, I is connected to input is connected to Y0. So that the moment when it is connected to Y0, then only Y0 will be 1 and all remaining will be 0. And now the moment when we apply S equal to 1, what will happen, sir? Here the input will be connected to Y1 here, which means Y1 will be 1 and all remaining are 0. This is what truth table, and based upon this truth table, let me try to construct the logical expression. Here the third one is logical expression. How to write a logical expression, sir? Here Y0 equal to, or we can say Y equal to, here S is 0, which means S bar into, we can say Y0, plus here S is 1, which means S into, we can say Y1. This is what the logical equation. And for this particular logical equation, let me try to construct the logical circuit even. The fourth one is logical circuit. The logical circuit for this particular logical equation is, here we can say that these are y0 and y1, and now here this is S, and now let me take here S bar even. Now sir, here the first AND gate is for y0 and for S bar, here first AND gate, and second AND gate is here for y1 and we can say for S, and this is second AND gate. For these two, finally we need to take one OR gate. This is the final output Y. So this is the analysis of demultiplexer, and the same analysis even applicable for even 1 into 4 demultiplexer we can say, and 1 into 8 demultiplexer, even 1 into 16 demultiplexer. This is the basic procedure, and after understanding this procedure and the procedure of understanding 1 into 4 multiplexer even, after that we will see how to construct a 1 into 8 multiplexer with the help of 1 into 2 multiplexer. We can say how to construct higher order demultiplexers with the help of lower order demultiplexers. Thanks for watching. Please do subscribe.